Hi everyone, myself Kutala Kumaran from Mechanical Department. I'm going to give a presentation on electric vehicles. Contents: Introduction, History, Types of electric vehicle, Comparison of batteries, Motor classification, Battery swapping, Advantages, Problems faced by EVs, Future. Take the low vehicle penetration table column. The two-wheeler has more usage when compared to buses and passenger vehicles. So that if we change the two-wheeler as a electric vehicle, so that noise pollution and air pollution can be reduced. Introduction: An electric vehicle uses one or more electric motor for propulsion. Electric vehicles are becoming increasingly important as not only do they reduce noise and pollution, but they also can be used to reduce the dependence of the transport on oil, providing the power is generated from the fuel other than oil. Electric vehicles can also used to reduce the carbon emissions where they are eco-friendly also. History: The first known electric locomotive was built in 1837 by the chemist Robert Davidson and was powered by non-rechargeable batteries. Davidson later built a large locomotive which was exhibited on the Royal Scottish Society of Arts exhibition in 1841. The first use of electrification on a main line was on 4 mile stretch on the Baltimore Beltline in the USA in 1895. If you see this diagram flowchart where the electric vehicles as a golden times in 1890 to 1924, where they have emerged and very popular in this on this years when the gasoline vehicles came into picture due to the low cost of the oil, so the EV get disappears and the gasoline is dominated. By the 1920s, several hundred thousands of electric vehicles has been produced for the use as a car, van, taxis. However, despite the promise, the early electric vehicle, once the cheap oil was widely available and the self-starting of the IC engine has arrived, the IC engine proved a more attractive option for the powering vehicles. Types of electric vehicle: battery electric vehicle, hybrid electric vehicle, fuel cell electric vehicle with supercapacitors and flywheels, solar power vehicle. Battery electric vehicle is a type of electric vehicle that exclusively uses chemical energy storage in rechargeable battery packs with no secondary source of propulsion such as hydrogen fuel cell and IC engine. Battery electric vehicle use electric motors and motor control instead of IC engine for propulsions. If you see the diagram, only the battery and the motor is used for controlling the propulsion of the vehicle. Hybrid electric vehicle. A hybrid electric vehicle is a type of hybrid vehicle that combines the IC engine system with the electric propulsion system. The presence of electric powertrain is intended to achieve either better fuel economy than the conventional vehicle or better performance. There is a variety of hybrid electric vehicle types and the degrees to which each function as a electric vehicle also varies. The most common form of hybrid electric vehicle is the hybrid electric car, although hybrid electric trucks and buses also exist. If you see the diagram, where IC engine works as a generator to generate the power and store in batteries, while the traction motor is connected to the gearbox and used for propulsion of the vehicle. Fuel cell electric vehicle. A fuel cell vehicle is a type of electric vehicle which uses a fuel cell instead of battery or in the combination with a battery or supercapacitor. To power its onboard electric motor, fuel cell in a vehicle generates electricity to power to the motor, generally using oxygen from the air and compressed hydrogen. Most fuel cell vehicles are classified as zero emission vehicle. They emit only water and heat. This is the model of the fuel cell car where the hydrogen is filled in a tank where it is sent to the fuel cell. The air from the atmosphere is sent to the fuel cell with the oxygen and hydrogen combines to produce the electricity. and it is stored in a battery and used in a motor for the propulsions. EVs with supercapacitors and flywheels. There have been various alternative energy storage devices including the flywheels and supercapacitors. As generally rule, both of these devices have been specific power and which means that they can take it and give out energy very quickly. Although they can do this, the amount of energy they can store is currently rather than small. In other words, although they have good power density, they have a poor energy density. This is a picture of flywheel. A solar vehicle is an electric vehicle powered completely or significantly by direct solar energy. Usually, photovoltaic cells contained in solar panels convert the sun energy directly into electricity. In term, solar vehicle usually implies the solar energy is used to power or are a part of electric vehicles propulsion. Comparison of batteries: nickel metal hydride batteries and lead acid batteries. Specific energy of nickel metal hydride battery is 40 to 80 and energy density is 90 to 160. Specific power is 900 to 1600. Charge and discharge efficiency is 80 to 90 percentage. Self discharge rate 8 to 15 percentage per month. Cycle durability 800 to 1200 cycles. Nominal cell voltage is 1.2 volt. Lead acid batteries. Specific energy is 30 to 40. Energy density is 60 to 90. Specific power is 250 to 600 watt per kg. Charge and discharge efficiency is 75 to 90 percentage. Self discharge rate is 5 to 15 percentage. Cycle durability 500 to 800 cycles. Nominal cell voltage 2.1 volt. Nickel cadmium batteries. Self specific energy is 40 to 60. Energy density is 80 to 140. Specific power is 300 to 800. Charge and discharge efficiency is 75 to 93. Self discharge rate is 5 to 15 percentage per month. Cycle durability is 800 to 1200 cycles. Nominal cell voltage is 1.2 volt. Lithium ion batteries. Specific energy is 130 to 200 and the energy density is 180 to 320. Specific power is 1200 to 4000. Charge and discharge efficiency is 85 percentage to 96 percentage. Self discharge rate is very less than 5 percentage per month. Cycle durability 1500 to 2000 cycles. Nominal cell voltage 3.75 volt. As we compare the four batteries, where lithium ion battery has the more specific energy and energy density, where the cycle durability also high and self discharge rate is also high, so that it can store the energy more. Motor classification: electric motors has two types: AC and DC motor. AC has three types, where asynchronous, synchronous, and variable reluctance. Asynchronous as a induction motor, synchronous as a sinusoidal, brushless, and reluctance. Wherein sinusoidal as a permanent magnet and wound field motors. In variable reluctance, they have a stepper reluctance and a stepper motor. Brushless DC motor. A brushless DC motor is a direct current electric motor that operates without the mechanical brushes and commutator of a traditional brush motor. It is a distinct advantage over a brush motor and is more economical in the long run, although initial costs are high. This is how the BLDC works, where the EMF is produced in the stator and the rotor gets rotated. Permanent magnet synchronous motor. A PMSM motor uses permanent magnet embedded in a steel rotor to create a constant magnetic field. The stator carries winding connected to an AC supply to produce a rotating magnetic field. A synchronous speed, the rotor poles look at the rotating magnetic field. The permanent magnet synchronous motor are similar to BLDC motor. Neodymium magnets are the most commonly used in these motors. This is also a working model of PMSM motor. Induction motor or a synchronous asynchronous motor is an electric motor in which the electric current in the rotor need to be produced. Torque is obtained by electromagnetic induction from the magnetic field of the stator winding. A motor can therefore be made without electric connections to the rotor. A induction motor's rotor can be either wound type or a squirrel cage type. Where the rotor is surrounded with a stator with the copper windings where the EMF is produced and the stator gets rotate. Hub motor. The wheel hub motor is an electric motor that it is incorporated into the hub of the wheel and drive it directly. Chargers. There are three type of chargers: fast, slow, and moderate. These are the types of chargers. Combined charging system (CCS), with the output voltage of 200 to 750 volts, and Chordy move, which has the output voltage of 200 to 500. Type 2 AC of 380 to 415 volts. Slow and moderate charges. Bharat DC 001. These are the one of type as output voltage of 48 volts. Bharat DC 001, which has another type of voltage as 72 volts. Bharat AC 001, 230 volts of the output voltage. These are the picture of different types of chargers. Battery swapping. One way to charge EVs is to charge the batteries. When it is removed from the vehicle and replace it with a full charged one, the batteries could be stored charged in a warehouse. For example, when you are waiting to put in a vehicle, it takes more time. Denmark has recently introduced a battery swapping station in which lithium-ion batteries weighing around 250 kg can be replaced in a specially designed car in around 5 minutes so that you can reduce the timing for the charging. Advantages: EV releases no tailpipe air pollutants at the place where they are operated, where they typically generate less noise pollution when compared to IC engines. A study of Cambridge Econometrics show the potential air pollution benefits of EVs. According to the study, Europe would be on a track to reduce CO2 emissions by car by 80% 2050. The state technology improvements would cut the nitrogen oxides from car around 1.3 million tons per year to 70,000 tons per year. It's a huge reduction of the NOx. Problem faced by EVs: temperature versus energy consumption. HEVs are not able to fully utilize the hybrid function until the cabin. To some extent, the batteries are at operating temperature. The range of battery electric vehicle range could drop by one half of the except for typical driving if there is a extreme traffic jam during inclement winter weather. If you see the flow chart, the Nissan Leaf at the hotter temperature has a less efficiency where it consumes more energy, where in a colder weather where it is a high efficiency. Comparison of Indian vehicles: Hyundai Kona, e-Verito, Tiago, E2O Plus, and Nexon EV. Motors: with the Hyundai Kona and Nexon uses PMSM motors, and e-Verito, Tiago, E2O It uses three-phase induction motors, where everyone uses the battery same as the lithium-ion batteries, where the range differs from car to cars. Where a Hyundai Kona of 452 kilometers, and EV2 140 kilometers, and Tiago 213 kilometers, E2 plus 140 kilometers, and Nexon 312 kilometers. Chargers. The fast charging Kona takes 57 minutes for 80%, and EV2 takes 80 minutes for 80%, and Tiago takes 120 minutes for 80%, where E2 takes 1 hour 35 minutes for 80%, and Nexon takes 60 minutes for 80%, where E2 takes more time for the charging. Home charger. Kona takes 6 hour 10 minutes, EV2 takes 8 hour 30 minutes, Tiago takes 11 hour 5 minutes, E2 takes 7 hour 20 minutes. The portable chargers in Kona and Nexon, where portable charger in Kona takes 19 hours and Nexon takes 8.5 hours, where the portable chargers are can be carried with us wherever it can be charged. Table column of foreign cars. If we take Nissan Leaf, it takes 16 hours in a cord set charger and 5 hours in wall mount charger. Where it's a DC fast charger, it takes only 20 minutes for the 80% of the charge to fulfill. In Tesla S model, in a cord set charger, it takes 60 hours. In a wall mount charger, it takes 15 hours. Whereas in DC fast charging, it takes only 40 minutes for the 80% of charge. Future. Toyota is trying to replace the lithium-ion batteries with the solid-state battery technology by 2020. The solid-state battery replaces the liquid electrolyte with the solid electrolyte. Rechargeable lithium air batteries potentially offer increased range over the other types are a current topics of research. Improvement to the decouple the motor from the battery through electronic control, employing supercapacitor to buffer large but short power demands and regenerative braking system. Thank you.